Millions of people take a pill every morning to help them focus. It's one of the most prescribed medications on the planet. Doctors recommend it, studies support it, parents trust it. There's just one problem. That's not actually what it does. In December 2025, a research team at Washington University scanned the brains of almost 12,000 children. They wanted to know, once and for all, what ADHD medication is actually doing inside the brain, and what they found hadn't been seen before. The medication wasn't targeting attention at all. It was doing something else entirely. Something that, once you see it, makes ADHD look completely different from the story we've been told. Okay, before we get into the new science, let's make sure we're on the same page, because ADHD isn't just being distracted. That's the shorthand, but it's not really accurate. The real picture is more interesting, and honestly, more uncomfortable. The brain has a management system. Scientists call it executive function, and it runs three main operations. First, inhibition. That's the ability to stop yourself, to not say the thing you shouldn't say, to not open a new tab when you're supposed to be working, to pause before you act. Second, working memory. Think of it like your mental whiteboard, the place where you hold information while you're using it. Following a conversation, remembering the first part of a sentence while you're reading the last part. Third, cognitive flexibility. Switching between tasks without completely falling apart. Adapting when plans change, letting go of one thing to pick up another. Now, here's what most people get wrong. These systems aren't simply broken in ADHD. They're inconsistent. They're variable. They work fine for some things and not at all for others. The classic example. A kid who can't focus on homework can play video games for 6 hours straight. No medication, no effort, total absorption. That's not laziness. That's not a choice. That's actually one of the most revealing clues about what ADHD really is, and we'll come back to it. For decades, that executive function story was the whole explanation. ADHD equals executive function deficit. Done. But three research teams across 2025 and 2026 started asking questions the textbooks never did, and what they found wasn't a rewrite of what we knew. It was the parts of the story that were always missing. The team at Washington University had something unusual: access to resting state brain scans from almost 12,000 children. Resting state meaning the kids weren't doing any tasks, they were just lying in the scanner. The machine was watching their brains at rest. Some of these kids had taken their ADHD stimulant medication that morning. Some hadn't. The researchers compared the two groups. Now, before the results, let's be honest about what everyone expected. ADHD is supposedly an attention disorder. The medication is supposed to fix attention, so logically you'd expect to see changes in the brain's attention networks. That's not what happened. The attention networks essentially unchanged. Instead, the medication changed two completely different systems. The arousal system, the network responsible for wakefulness, for alertness, for that baseline level of activation that determines whether your brain is switched on or not. And the reward circuits, the system that evaluates, is this task worth the effort? Should I keep going or find something better to do? The stimulant medication isn't making the brain better at paying attention. It's changing how the brain perceives the value of a task. The thing that makes video games feel easy to focus on, and applying it to math homework. The researchers described it as the medication pre-rewarding the brain. But the study doesn't stop there. Because when the researchers compared the brain patterns of medicated ADHD kids to simply well-rested kids, the patterns were nearly identical. The medication was essentially doing what sleep does, bringing the brain into a state of wakefulness and readiness that adequate rest would have provided naturally. Now, I want to talk about something that should make anyone who's been touched by ADHD genuinely angry. For most of the history of ADHD research, the studies were done almost exclusively on boys, which sounds like a footnote. But it isn't. Because the diagnostic criteria, the symptom descriptions, the clinical training, all of it was built on that research. And so for decades, ADHD looked like hyperactive boy. Girls and women with ADHD tend to internalize. They tend to mask. Where a boy with ADHD might be visibly disruptive, a girl with ADHD is often just quietly exhausted, putting enormous effort into appearing fine, organized, together. By the time many women receive a diagnosis, they've often already accumulated years of depression, anxiety, burnout, and damaged self-esteem. The 2025 review, written by more than 30 researchers across Europe, documents this in detail. And it adds a dimension that makes the picture even more complex: hormones. Here's what this study pulls together. Estrogen and dopamine are deeply, intimately connected. Think of estrogen as something that keeps the dopamine system running smoothly. In the ADHD brain, where dopamine signaling is already different, this relationship matters enormously because estrogen fluctuates. It rises and falls with the menstrual cycle, with pregnancy, with perimenopause. And every time it drops, for a brain that was already working hard to keep dopamine functioning, the floor drops out. The data from the study is stark. In the week before their period, when estrogen is at its lowest, 80% of women with ADHD report significant irritability. 66% say their focus and concentration become severely impaired during the postpartum period. And this is what makes it so consequential. Women with ADHD are diagnosed significantly later than men. They're more likely to be misdiagnosed with anxiety or depression first, and even when they do get the right diagnosis, they're less likely to receive medication. The third piece of research is the one I find most affecting, because it addresses something that gets said about kids with ADHD all the time, in classrooms, in assessments, by teachers and parents who are genuinely trying to help, that the learning isn't sticking, that the information isn't going in, that the child isn't engaging. A 2026 study from the University of the Basque Country suggests that in a very specific and important sense, that conclusion is wrong. Here's the experiment. 88 kids, half with ADHD, half without aged. 8 to 16, they're given a simple task, count how many flowers appear on screen. That's it. That's the instruction. What they don't know is that there are two kinds of flowers. One type has 5 petals, the other has 6. Visually, they're almost identical. Half the kids see the flowers alternating, 5 petals, 6 petals, 5, 6, switching back and forth throughout the task. The other half see all the 5-petal flowers first, then all the 6-petal ones in a separate block. Then, completely without warning, the counting task ends and a new task begins. The researchers show 2 flowers side by side and ask, are these the same or different? And if they're different, how? Here's what the data showed. Both groups, kids with ADHD and kids without, were significantly better at detecting the difference when they'd seen the flowers alternating. But here's the second layer. When researchers asked which specific feature made the flowers different, can you name it? Kids with ADHD could do this less than half the time, even when they correctly detected the difference. The control group named it more than 80% of the time. Think about what this means outside a laboratory. Tests ask you to verbalize, essays ask you to organize and articulate, oral exams ask you to produce structured language under pressure. These are all tasks that rely heavily on the very functions that ADHD affects: working memory, cognitive flexibility, the ability to consciously access and sequence what you know. And what this study shows is that a child might have learned the material genuinely, fully, and still fail to demonstrate that knowledge in those formats. Not because the information isn't there, but because the bridge between knowing and saying is harder to cross. What changes when you hold all of this together? Maybe the way you think about why medication helps. Not as a focus booster, but as a motivation stabilizer. Maybe the way you respond to a woman who's been struggling for decades and just got a diagnosis in her 40s because the system wasn't built to see her. Maybe the way a teacher evaluates a student who clearly understood the discussion but couldn't produce the essay, and whether can't produce the essay is the same as didn't learn. Science doesn't change overnight. Neither do institutions, but the research does, and it's moving.